Hello, students. Myself, Jitan Kumar Chauhan from ABES Engineering College. Today, we will going to discuss about the one of the most important protocol, which is known as DNS. That is Domain Name Services, which is an application layer protocol. So we can say that we can already talk about the other application layer protocols that were designed to make it easier to obtain the addresses for the network devices. So these services are essential because it would be very time consuming to remember the IP addresses instead of the URLs, or manually configure all of the devices in a medium to large networks. So basically, as a human being, we are basically easy to remember the domain name instead of the IP address, which is a numeric number. So in data networks, the devices are labeled with the numeric IP addresses to send and receive the data over the networks. The domain names were created to convert the numeric addresses into the simple recognizable name. So on the internet, there's a fully qualified domain name, which is basically comprising the protocol. We have the website name, and are the much easier for the people to remember than the IP addresses. For example, if this server have the IP address 192.133.219.25, which is the actual numeric address for this server. So if Cisco decides to change the numeric addresses, www.cisco.com, and it is transparent to the user because the domain name remains the same. So the new address is simply linked to the existing domain name and connectivity is maintained. So the DNS protocols define an automated services that matches the resource name with the required numeric network addresses. It includes the format for the queries and response and the data. So the DNS protocol communication uses a single format called a message, and the message format is used for all types of client queries and the server responses, error messages, and the transfer of resource record information between the servers. So for example, in case of the DNS, the step 1, the user type the fully qualified domain name into a browser application address fields, like we can type the http://www.cisco.com/. So this is a fully qualified domain name. So this basically request, the name is easy for people to use. So this request is moved towards the DNS server. So here, the DNS step 2, the DNS server is sent to the designated DNS server, which basically maintain the entries of that particular, you can say the domain name for the client computer. And then it can resolve the queries. That means what basically the IP address of this particular domain name is basically towards that designated server. In the step 3, the DNS server matches the fully qualified domain with its IP address. For example, it contains the resource records, which contain the fully qualified domain like www.cisco.com and its correspondingly IP address 182.133.219.25. So this server basically uses this device number, which is the IP address of this number. So here the DNS server matches the fully qualified domain with its IP address, and then in response, the DNS query, then response is sent back to the client with the IP address for the fully qualified domain. So this is how the query and the response messages works. In the step 5, the client computer uses the IP addresses to make the request of the server. So in the next time, when we have to communicate towards a particular client, then it can basically uses this IP address, which is a 192.133.219.25 towards a particular cisco.com server. Now, the DNS server stores the different types of resource records that are used to resolve the names. So these records contains the name, address, and the type of records. And some of these records, for example, the 4 types like the A, NS, Quad A, or MX. So A basically the end devices use an IPv4 addresses. NS is basically it's an authoritative server. Quad A is basically an end device using IPv6 addresses. MX is a mail exchange records. So when a client makes a query, the server DNS first looks at its own records to resolve the name. If it is unable to resolve the names by using its stored records, it contacts to the other servers. Basically, these servers are in a hierarchical order. So it basically moves from the top level domain servers towards the authoritative servers. So after a match is found and returned to the original requesting server, the server is temporarily stored the number addresses in the event that the same name is requested again. So it catches the entries so that the next request is fulfilled from that catch. So here we can say the DNS client services on the Windows PCs also store the previously resolved names in the memory. like your IP config, get display DNS commands, display all of the cache entries, DNS entries, which you queries earlier. So here we can, in case of these DNS record descriptions, the same messages format between the servers consisting of the questions, answers, authority, and additional information for all types of client queries and server responses, error messages, and transfer of the resource records. For examples, what kind of questions or to for this name server, the answers, which is the resource records answering the questions, authority, the resource records pointing towards an authority here, or the additional resource records holding the additional information here. So the DNS server basically uses a hierarchical system. Basically, it contains the hierarchy of tree from the root node to the leaf node. The database to provide the name resolutions. For example, the DNS uses the domain names to form a hierarchy. The naming structure is broken down into the small manageable resource zone. Each DNS server maintains a specific database files and is only responsible for managing the name to IP mappings for that small specific database file and is only responsible for managing name to IP mapping for that small portion of the entire DNS structure. So when a DNS server receives a request for a name translation that is not within the DNS zone, the DNS server forwards the request to the another DNS servers within the proper zone of the translation. The DNS server is scalable because the host name resolution is spread across the multiple servers here. So, for example, if we can have the four different domains, the examples of the top level domains are the .com for the business industry, .org non-profit organization, .au for Australia, .co is for the Colombia, .in is for the India, and so on. So here we can, let's see the figures. The DNS hierarchy tree at the top is the root level domain with the top level domain here, which is known as the TLDs, connected underneath the root level domain name. The TLDs are the .net, .edu, .com, .au, .co, and other top-level domains. Under the .com TLDs is the second level is the w.cisco.com. Under the cisco.com are the w.cisco.com, ftp.cisco.com, and mail servers like the FTP server or the mail server here. So this diagram can represent the root level. Then under root level, there's a TLD domain servers, .net, .edu, .com, .au, .co, and other top-level domain servers. And under, for example, the .com servers, we can talk about a fully qualified domain as well, like the cisco.com contains the main websites here of the FTP server, or we can have the mail server. So these basically represent the IP address scheme in the DNS hierarchy manner. Now, we can have the another command, which is an NS lookup command. So when configuring a network device, one of the more DNS servers addresses are provided that the DNS clients can use for the name resolution. So usually the ISP provides the addresses to use for the DNS servers. So when the user applications request to connect to a remote device by name, the requesting DNS client queries the name servers to resolve the name to a numeric address. So the computer operating system also have a utility called the NS lookup that allows the users to manually query the name servers to resolve the given host name. So here the browser can do this task, but you can also manually do this by using the NS lookup command. This utility can also use to troubleshoot the name resolution issues and to verify the current status of the name servers. So when the NS lookup command is issued, the default and DNS service is configured, your host is displayed. The name of the host or the domain can be entered at the NS lookup prompt here. The NS lookup utility has many options available for extensive testing and verification for the DNS process. So this is how the DNS lookup can works. In a command prompt, you can type this NS lookup. Here you can give the default server name, addresses, server entries, address here, the name origin server, addresses, and other, you can say the aliases, which is the name of that particular domain, which is at w.cisco. Or we can type that the cisco.netacat.net. So again, the server name and address resolutions we can see here by using the manually NS lookup command. These are the references used for this lecture. And this is the disclaimer. Thank you.